Hello everyone, we're going to talk today about the product rule. So hopefully you have your notes in front of you, and here we go. First, the product rule. We use the product rule to take the derivative of two things that are being multiplied together. So for example, if our equation is y equals u times v, then we would take the derivative by doing y prime equals, and you can see it written right there. Now in words, the way we write this is you keep the first term, so you keep the u, and you differentiate the second term, that's the v prime, and then you add the second, you keep the second, and you differentiate the first. So you always have to think you're going to break this into parts. One of them is going to take the derivative, the other one's going to stay the same, and then for the second one you flip that option around. So here's an example. We have two functions, 2x squared minus 1 times 3x plus 4. So we take the first, and then we do the derivative of the second, plus the second times the derivative of the first. So you can see here that what we did is you have the first, which is 2x squared minus 1, you leave that alone, and we're going to times the derivative of the second, the 3x plus 4, and then for the second term we flip that around. So the 2x squared minus 1 in the first term, that's going to stay the same, and then the derivative of 3x plus 4 is 3. For the second term, 3x plus 4 stays the same, and then you multiply it times the derivative of the 2x squared minus 1, which is the 4x. Distribute those across, and then you combine like terms and you get your final answer, 18x squared plus 16x minus 3. Now some of you may be saying, now couldn't we just multiply that first and use the power rule? And yes, in this case you could simply FOIL that top term out and then use the power rule. So for example, 2x squared minus 1 times 3x plus 4, if you FOIL that out, you get 6x squared plus 8x squared, 6x cubed plus 8x squared minus 3x minus 4, and then you can take the derivative using the power rule. Basically, you have several different ways that you can do this problem, but in some cases you can't FOIL first. As an example, this one, x times cosine of x. We can't FOIL first, so we are required to use the product rule. So for this function, the first term is x and the second term is cosine x. The derivative of the first term is 1, the derivative of the second term is negative sine x. Using the product rule, and there it is, we're simply going to partner those up and pair them up and multiply it out. So u was x and v prime was negative sine x, and you can see the way that that worked out. And then you rewrite it, and that's your final answer. And we'll do a couple more examples. You can rewrite it in any order. Either one of those last two would be a fine answer for me. Let's do another example. 4x times sine x. The first term is 4x, the second term is sine x. The derivative of 4x is 4, the derivative of sine x is cosine. There's the product rule. Plug the numbers into the proper spots, simplify, and you're done. All right, that's it. That is the product rule. Okay, I think I have one more example. 3x squared plus 3x plus 2x squared times x squared minus 5x. The first term times the derivative of the second plus the second term times the derivative of the first. And so there you can see the first term times the derivative of the second plus the second term times the derivative of the first. You have to FOIL the left and FOIL the right. So FOIL the left, FOIL the right, combine like terms. That's your final answer. Okay, so then that brings us to the quotient rule. For the quotient rule, when you're dividing, so instead of multiplying u times v, this time we're dividing u divided by v, there's the formula that you want to write down. In words, the way you say that is, you keep the denominator and differentiate the numerator, then you subtract, you keep the numerator and differentiate the denominator, and then you divide by the denominator squared. So you want to write that down so that you can remember what's going on in the order that you have to do things. And there's a neat little thing that you can use to help you memorize this, and the way I remember it is, if you're taking the derivative, low d high minus high d low over the square of what's below. So you can have a little phrase there that you can remember. So you can come into class singing tomorrow, low d high minus high d low over the square of what's below. That's the only time I'm ever going to sing for you guys. Alright, so here is the derivative Or here's the question we're being asked to take the derivative of, and you can see that it is a quotient. So the top is the u is x squared minus 1, so u prime is 2x. The bottom is x squared plus 1, so v prime is 2x. There is the quotient rule. So we're going to plug them into the corresponding spots. And so the v is x squared plus 1 times u prime is 2x minus u is x squared minus 1 times v prime is 2x divided by the square of the bottom. Now we have to do some algebra and simplify this. Generally speaking, the algebra part is the hardest part of these problems. People, if you're going to make a mess, if you're going to make a mistake, that's where you wind up making a mistake. So we distribute. Now here's what I did is I saw that they had 2x in common, so I factored out the 2x, which left me with an x squared plus 1 minus an x squared minus 1. Distribute the negative across, and the 1's cancel, and the x squareds cancel, and the 1's get added and make 2. And so then your final answer is 4x over x squared plus 1 squared. Okay, I'll give you another example. X divided by x squared plus 1. Alright, so see if you can follow along. In the top term, x squared plus 1, that's the low, times the derivative of the top, that's the d high, minus the high, which is the x, times the derivative of the low, over the square of what's below. So now I'm on the second line. X squared plus 1 is the low that's left alone. The derivative of the top is 1, minus the top, which is the x, times the derivative of the bottom, which is the 2x. Distribute that across and simplify, and you wind up getting x squared plus 1 minus 2x squared on top, and then when you reduce and simplify, you wind up getting negative x squared plus 1 over x squared plus 1 quantity squared, and that's your final answer. Okay, I think I have one, maybe two more. X sine x, x divided by sine x. So if we set that up, low is sine x, d high is the derivative of x, minus high, which is x, d low, the derivative of sine x, over the square of what's below. So the derivative of x is 1, so sine x times 1 is just sine x. The derivative of sine x is cosine x, so x times cosine x, and you see your answer. Okay, let's do one more. I think there's one more. X squared minus 3x minus 1 over x. I'm going to show you two different ways. First, I'm going to do this with the quotient rule. So I have low, which is x, d high, which is the derivative of x squared minus 3x minus 1, minus high, x squared minus 3x minus 1, d low, which is the derivative of x, over x squared. So in the second line, x times the derivative of the top is 2x minus 3, minus the top times the derivative of x, which is 1. Distribute the x across, you get 2x squared minus 3x. Distribute the negative across, combine like terms, and you get your answer. Now I'm going to do this one another way. What if, since I'm simply dividing by x, what if I simplified first? So I split it up, and I divided x squared divided by x, negative 3x divided by x, 1 divided by x, and then I rewrote all those into powers, and then I found the derivative just using the power rule. So you can see that I did that, and then if you simplify, and I had to find a common denominator, and you notice you get the exact same answer that I got before. It's just a different way to do it. So a lot of times there's more than one method that you can use now that we know these different rules, and you have to decide which one is the fastest and which one is the most efficient way to go. So more videos can be found at www.calculushelp.com, and I encourage you to go and look at those for product rule and quotient rule if you have any questions, and I will see you in class.